Hi, everyone. Thank you for coming. So first of all, really great to see so many people have signed up to this webinar. This is not the first time we've done a webinar like this, and it's really good to see the number of people that are interested in this topic and joining our series of webinars is going up. So it's really exciting. So my name is Simon. I'm a partner at Cleverbit, and I run the commercial function within the business. Um, um, do you want to introduce yourself?
Yeah, thanks, Sam. So, hi, I'm Owen. I'm the CTO. I've worked in the tech industry for about 15 years, and my background is software development. And nowadays, I'm mostly focused on team performance, and AI obviously plays a very, very big part in that.
Super. Thanks, Sam. So just before we start, just a quick thing in terms of what we do at Cleverbit. So Cleverbit is we're a software company, and what we do is we partner with typically regulated businesses and large enterprise clients to help them with software development, with leveraging technology, leveraging AI within their SDLC. And making sure that there's best practices and right governance in place to take advantage of this opportunity. This webinar is meant to be very casual, so we're looking to do this as frequently as possible. So therefore, we're not polishing the conference, the webinar itself, but really focusing on making sure that the content is as effective and as relevant to the people that attend. Do you want to take it away?
Yeah, thank you.
Thank you.
Right, so let me share my screen. We're getting started. Right, so we're starting with the why. So why we're talking about AI and the SDLC, and as we know, models and tooling keep improving. Yesterday, we had the release of Opus 4.7, and I think a lot of us agree that AI in software development has really improved over the past months. And companies are automating a lot through AI, but at the same time, we also hear of the scary stories of the security breaches and the major outages, often by the same companies. And I think one of the main reasons as well is that most advice out there is relevant to individuals or at best very small, very agile teams, where these teams can take all of the decisions, including deployment cadence, tooling use, and even security. And this advice doesn't really apply to the enterprise or especially regulated businesses. All right, so what are we covering? So first of all, we're going to look at the cutting edge, so what the companies at the frontier are doing with AI. Then we're going to look at what we call vibe code drift and what controls we can put in place to avoid vibe code drift and other things, and also what a governed operating model looks like so that we can control these things at an organization level. All right, so starting off with the AI frontier, we're going to look at a couple of examples of companies taking AI to the extreme. So this is something we're hearing very often, especially from big tech CEOs, that developers aren't writing code anymore. And it's definitely the case. So developers are relying a lot more on AI now. And recent reports show that 90% of developers are using AI. So there's no doubt that the developer job is changing. And I think this isn't just happening at big tech, this is happening in most companies. But this is a surface level claim, and we need to understand what this means in terms of output, and especially what this means in terms of risk. And using AI, when using AI in dev, there are various levels to automation. And before we look at the examples, we want to look at this framework to help us with the terminology. So Dan Shapiro came up with this framework a couple of months ago. I think published this in January. And he gives us fancy ways to refer to the different stages across this spectrum. And the first level he calls spicy autocomplete. So this is the autocomplete that we're used to, just better now with LLMs. And in this case, the information that the developer needs is surfaced in the IDE. So the biggest benefit of this is that the developer has less context switching, so they need to Google less, they don't need to go to Stack Overflow. But very importantly, in this stage, in this level, the developer is working very, very closely with AI and understanding or reviewing or looking at all of the code that they're producing. On the other end of the spectrum, then Shapiro calls this dark factory, which is a manufacturing term. So in manufacturing, this is when you have robots running your factory, so you can basically turn off the lights. In software development, this is when humans are writing specifications, but then everything else is automated through AI. So these are the extremes. So we're going to look at a couple of case studies, a couple of examples. And the first one is Cloudflare. So most of you have heard of Next.js. It's a very popular React framework. Most React projects use Next.js. And Next.js is by a company called Vercel. Now, the problem with Next.js is that it's very hard to host outside of the Vercel's environment. So usually the way you do this is to use a project called OpenNext. And Cloudflare, being a hosting company, have invested quite a bit in this OpenNext project. But it's quite a patchy solution. So anytime that Next.js is updated, this OpenNext project breaks and needs to be patched all over again. And an engineering manager at Cloudflare, I guess, was fed up of the situation and came up with this crazy idea to solve this problem. And his idea was to rewrite Next.js in a way that it can be hosted much easier. And he actually did this. So he rewrote most of Next.js. It took him about a week and about $1,000 worth of tokens. And he actually rewrote it. Now, the reason he could do this is that, like we said, Next.js is very popular. It's a very mature project, and it has over 1,000 automated tests. It has extensive documentation, and it's also definitely part of the model's training data as well. So he had a bit of an unfair advantage over most projects that we work with. Now, an even more extreme example is StrongDM. So StrongDM is a small company. It's a 3-man team, and they do security software, which is even more interesting. And they probably popularized the first implementation of a dark factory. So they have these two rules. Humans can't write code, and humans cannot review code, which is what makes it a dark factory. So they write everything in plain English. So they write the specifications, and they also write the tests in plain English. And the way they test their software is that they have AI do the testing. So AI runs thousands of tests across various scenarios and then scores how likely a user would have been happy with the result of those tests. And if it's over a certain threshold, then it's a pass. And they do this because they've invested quite heavily as well in their test harness. So they created digital twins of any APIs that they use, like they use Okta and Slack, for example. And that means that they can run these thousands of tests without incurring any costs or getting throttled by the APIs that they use. All right, so most of us have heard of those stories, they've been in the headlines, but not a lot of people are looking at the flip side of that. So when looking at VNext, so VNext is an open source project. As soon as the code was public, Vercel and others obviously jumped on it to audit it, and they found several issues, some of which severe issues. So they had things like cache poisoning, where data is stored across requests rather than being scoped to the request, which meant that users were sharing the same data. They have problems with authentication and authorization. So by double encoding URLs, you could basically bypass security. And then an interesting problem that they had was that in Next.js, there's an image optimization endpoint. And the way AI rewrote this in VNext is what the project is called. There's a try catch. And if the logic of the image optimization fails, it simply returns the raw image back to the user. But what this means is that if a user requests the optimization of a file that isn't an image, that logic fails because it only works on images, and it simply returns the file back. So users could access any file on the server. Now, what's worth keeping in mind here is that these were all design choices by AI, and that all of these issues still satisfied the 1,000+ tests that Next.js has. Then we're looking at StrongDM. So StrongDM is obviously not open source in terms of code, but they do have some publicly available code. The code is in Rust, and the community reviewed this code. And it's not great code, so there are various shortcuts, even on simple things. There's a lot of technical debt in the code and inconsistencies, which is typical of AI. And other than the code, they also received a lot of criticism on ownership. So owning what they ship when no one is actually looking at the code or testing anything really. And I think these two examples, they definitely show how capable AI is today, especially from a functional perspective. But it also shows how flaky what AI produces can be. So I think it reflects how careful we need to be with what AI is generating. Now, to close off these couple of case studies, so VNext obviously patched all of the issues, and they do have projects now running live in production hosted in Cloudflare. And StrongDM was acquired, and part of the reason that they were acquired was that the parent company wanted to internalize the way they implemented Dark Factory. So overall, I think they were still quite a success. Okay, and when looking at the frontier, it's quite scary. So a lot of us will feel like we're behind, and we also start to worry about what bugs AI is introducing in our code. And when people ask whether we're using AI, it sometimes feels a bit like a binary question. So we're either running a dark factory or else we're in the realm of using punch cards to write software. However, I disagree with StrongDM using a dark factory, especially given that they are a security company. I do think there is a place for dark factory, like in hobby projects or in internal projects or throwaways. But I think a dark factory exceeds the threshold that I call professional ceiling threshold. So to justify this argument, I want to bring up an analogy. So let's say you hire a contractor to build a house for you, and they do it. It looks great. It's exactly what you wanted. So you move in, and you're in the kitchen. You have the kettle on. You're making coffee because you're a developer, obviously. And you turn on the oven, and as soon as you do that, the electricity trips. So you call an electrician. They come and check, and they tell you that all the appliances, all of the house is running on the same circuit. So you call the contractor, and the contractor agrees it's a trivial mistake, but they just tell you that the cheap and fast subcontractors that they got should have thought about it, and they take no responsibility for this. So I think when clients or businesses hire a professional to develop software, they're expecting them to take into consideration things like security, like cost, like compliance, like maintainability. So professionals need to own the internals. The clients are not simply hiring professionals just to build software that meets their functional requirements. And I'm not saying that we should slow down in our use of AI. Actually, quite the opposite. We should use as much AI as possible within that spectrum, within the professional ceiling threshold, but never beyond that point, the point where you can take full accountability of what you're delivering. All right, so now let's look at vibe code drift, what we call vibe code drift. So the top part is the traditional SDLC. So we gather some requirements, we take some technical decisions, we spend quite a lot of time coding, then someone else reviews the code usually, and then we QA it, we test it. Now, the expectation, I think naively, was that you would give developers some AI tools. Code is done much faster, but everything else can remain the same, and we're moving much faster now. We're moving twice as fast. But what actually happens is that even though writing code is definitely faster, so there's a local speed there, reviews weaken, ownership starts to blur. We end up with what the industry is now calling dark code, so code that no one understands, which was always a thing. So it's not a new thing. It happened with employee churn, but now we're doing it from day one. And ultimately, no one knows whether we're moving faster or not. So we're writing code that's quicker, definitely, but we're not sure whether there are bottlenecks elsewhere because of this. And what's good, but also bad about AI is that today it can get it can get the functional quite right, and it also writes idiomatic code, like we've seen in the examples before. But that gives developers a false sense of confidence, which is what leads to what we're calling drift and all of the issues that we just mentioned. So you end up in a situation where you have a dark factory and a dark code, but without planning for it or knowing that it exists. So code generation is definitely easier and cheaper now. I think no one is debating this, but keeping that change, that code change, aligned to the intent, and then verifying that it is, are much harder than ever before. So because of that, your default position should be not to trust AI-generated code. And StrongDM got a lot of criticism because of this. So this is one of the main articles by Erin and Stanford Law School Codex. And his criticism was that you have AI certify or verify what AI is doing. So how can you trust the deliverables that they are producing? So in order to make sure that we're operating within the professional ceiling, I think we need a minimum we need these four things. So this is how you're checking the wiring and the contractor analogy, if you will. So we first need to look at what we're actually trying to achieve and what must always be true. So that's the intent. What are the requirements, the scope? Then we need to translate, a human needs to translate that intent into the technical, so architecture, the constraints. Then we need to somehow inspect the internals, so making sure that from a structure perspective, we are following the rules. And obviously, what we've always done, we need to confirm that the system behaves as intended from the outside, from the function perspective. So let's look at the operating model, so some of the controls that help us do this. All right, so we're starting with code review. So we said that code reviews weaken when we're using AI, so we need to look at why they do. So code reviews have never been an excellent tool, and there are multiple studies that show that the larger the change, the less effective code reviews are. So the problem is that with AI, this gets much worse. By default, AI adds a lot more change, and we can produce a lot more code now because we have AI. So it becomes just unmanageable for humans. Then there's also the fact that AI knows about all of the patterns, all of the conventions, so the code looks pretty, which can trick the reviewers. And there's a lot of pressure to move quickly. Now we're using AI, you don't want to be the bottleneck, so you just rubber stamp the code change. So how can we make that better? So there are best practices that we've always had. So you should have smaller changes. The reviewer should be briefed on what is changing before they actually look at the code. And then there are some newer things that we're doing. So first off, you can have AI do a first pass. So a typical flow now is that the developer submits a change, AI reviews the change, it goes back to the developer, they fix anything that needs fixing, and only then it moves on to a different reviewer. You can also focus the changes and the reviews. So the problem is that it's impossible to look at every single line of code and scrutinize all of the change. And because of this, the value of code reviews is diluted. So you want to have more focused reviews, and you can focus them in various ways. So you can focus code reviews by area. So you can use features like code owners, for example, in GitHub, and have the expert in that area review specific code changes. You can focus it by risk. So not all code changes have the same level of risk. And then what's very important as well is to do spot checks to identify any architecture drift and the type of inconsistencies that we mentioned in the StrongDM example. But very importantly, you shouldn't rely on code reviews as your only quality gate. Okay, so then there's the problem that AI fills gaps. So this is an example user story that we would have had before. It's a relatively vague story. And the problem is that when developers are given missing requirements, they either have context from things they've implemented before or from other meetings that they've had or discussions that they've had, or they go back and ask questions. And AI instead just has a tendency to fill those gaps silently. So because of this, we need to focus a lot more on the contract. So it now feels a bit like those movies where they ask for a wish and they get a lot of unintended consequences as part of the wish. And before we had AI, we were focusing a lot more on the code. So it's a lot more precise. It's a much better way to instruct the machine, obviously. But now, because we have something in the middle, the genie in the middle, we need to focus and put a lot more effort into explaining to that genie in the middle all of the detail. So the question with this is obviously, is it worth doing? And many are advocating for spec-driven, but is it worth it? And I think it depends on the context. Like a lot of these controls that we're mentioning depend on the context. And I think a simple example is that if your code is the product, so let's say you have a library, for example, you should probably be focusing more on the code rather than the contract. And there's a lot more value in focusing on the code there. But in other scenarios where the code is simply a means to an end, then it might be worth it to focus on the contract. And the reason it's worth it in those scenarios is that, first of all, we've always had missing intent in the requirements. So now you're focusing on it and we're fixing it finally. And we're making the implicit things become a lot more explicit. Then there's the fact that they're not equivalent in effort. So writing code is very messy and takes a lot more time. And a good benefit of this is that it moves us one step further away from legacy software. So whenever someone is attempting to migrate legacy software, a legacy system, the first question is, what does the system do? And the answer is usually this, but also things that we don't know about. So now we have the contract that explains in a lot more detail what the system is doing, and the code is becoming a derived artifact. So the contract becomes the source of truth. And it's just also more efficient to focus on the contract because you have less back and forth with questions going back to the business analyst, for example. All right, so what we need to do is we need to capture all of the negative space as much as possible. So AI has a few problems. So it has a tendency to change things you didn't ask for. And this evolved. So it's evolved from AI changing completely unrelated things to now being hyper-focused on the task. And that is the reason now that it changes things that it shouldn't be changing. And it also, AI has also a tendency to take the path of least resistance. So you ask it to implement password reset functionality, and it completely removes multi-factor authentication, for example. So in the password reset example, you might want to specify that you need logging. So a developer would know that such a request needs to be logged for auditing purposes, but AI wouldn't know, so it wouldn't implement that. And again, in this example, in this intent manifest, which is the contract that we're talking about, you need to specify that multi-factor authentication is out of scope. Do not change anything related to multi-factor authentication. Do not touch that feature. And then there's the direct instruction to AI. This is usually by the developer. So again, it's very important to remember that AI takes the path of least resistance. So recently I actually had a problem where I had an application and it wasn't managing to pull secrets from the vault. And I asked Claude to help. This was Opus 4.6, old model now. And its plan to fix this was to move the secret from the vault to a configuration. So obviously not the right approach. Again, it found that that was an easy way to fix it. And newer models are getting better at planning. There was a jump from Opus 4.5 to Opus 4.6, and apparently Opus 4.7 is even better, but these best practices are still very relevant. And some of the main things to keep in mind is that, again, you need to plan first, and this is a high leverage opportunity to review what's changing and catch issues as early as possible before you spend the tokens. You need to have small changes. Remember, code reviews, much better if the changes are small. And context is precious. So the best practice in terms of context is to stay within 50% of the context, because after that, models start to degrade. And even if they don't, it's just best practice because then you're forced to persist that context elsewhere. And then the planning phase is also a great opportunity to identify risk. So things are much clearer. So now you're looking at what files are going to change, what data flows are going to change, or what trust boundaries you're crossing. So risk is much clearer then. And we mentioned splitting the changes to help with pull requests or reviews. And ideally, your plan accounts for vertical changes and not horizontal changes. And the reason for this is just it's better for review again. So it's much easier for a developer or whoever is reviewing not to be looking at 15 different database table changes. And it also aligns better with feature flags, which we should also be implementing, of course. Now, I think a benefit of this approach of having AI do the planning or help the developer with the planning is that if the developer takes ownership of this planning phase, I think there's a nice consequence to this. So I think it starts to improve how developers think. So developers aren't so attached to the plans, so they start to criticize a bit more. So they get their review hats on, and they start to scrutinize the plans, and they start to think a bit more like testers, which I think helps create better plans. So a typical flow of what we just talked about would be that you create the plan, again, together with AI, you review the plan, you take into consideration making small changes and making it possible to have small PRs to be reviewed. You identify risk, then you persist the plan, very important to persist there, and you start a new session again. Ideally, you start a new session, context is precious as much as you can. You make the changes, and you repeat that until you've finished all of the changes, of course. All right, so that covers intent and instruction. But what about governance and process? And tooling has always been an attack surface, but now tooling is taking action on our behalf. It's non-deterministic, and we're giving it access to some sensitive data in the name of productivity. So we need to be focusing a lot more on the tooling itself as the attack service. So we need to move from just doing threat modeling on the system that we're building to doing threat modeling on the system that is doing the building. And we had Stride before, so now we have various frameworks to do this. So there is A-Stride, which adds A for agent. There's the OWASP Agentic Top 10, which covers a lot of the risks that come with agents. And things we need to be thinking about are things like prompt injection, obviously. So what levels agents are running with. So are they running with the user's identity, for example? Principle of least privilege, of course. So what input we're feeding AI, what access we're giving AI. Does AI need to have access to all of the pods? So we're giving AI access to the solution, but for example, does AI need to have access to the configuration part of the solution of the code base? And should we be excluding any? And we also need to be very careful with the tooling. So I don't know if you're using Claude Code, for example, I think at an organization level, by default, they don't train on your data, they don't store any of your data. But for example, in that case, there's a little loophole that Claude Code, there's a feature that Claude Code asks the developer for some feedback every now and then, and it's basically a rating from 1 to 10. And if the developer submits that feedback, it's actually storing all of the context on their service and having humans review that. So you need to be really careful with the tooling and how they're structured and control this as an organization level. Then there's also the skills trend. So a lot of people are now sharing these skills files, these MD files, which is obviously a great attack surface for prompt injection. All right, now we talked a bit about risk, and risk is not always obvious from the outset. So we need to evaluate risk at different points, which we mentioned a couple already. So at least at a minimum, we should have these 3 levels. So we're looking at risk at the contract level. Some changes are obviously higher risk than others. So if you're changing payment logic, it's obviously higher risk than a text change. Then you need to be looking at risk at the technical planning stage, so both at an architecture phase, but also the developer planning that we were talking about, because then you have a much clearer view of what is changing, and you should have some form of automation that is also looking at risk. So you can use AI to help you there and look at the risk as well. And the advantage of looking at risk and mapping risk across these changes is that it can help you with various things. So one of them is routing. So again, not all code changes need or deserve the same scrutiny. So the payment logic change that we mentioned definitely needs to be reviewed, but maybe a label change doesn't need that and just can be merged. Right. So you shouldn't trust AI to verify AI. Definitely not. Again, remember the Aaron criticism of strong DM, and you need to be comfortable with accountability, but that's not to say that AI isn't useful to test and review. So we already mentioned using AI to review code or surface risk. GitHub have just launched an experimental agent called RubberDuck that basically uses a different model to what you're using to review your code. And having different contexts and different models really helps because it's like getting different perspectives from different people. And Claude Code also has quite a few skills that help with this, like the security skill, for example. And we heard of how good cloud models are at security, especially with the Mythos thing. Now, a quick point on that Mythos thing is that Mythos is certainly impressive, but there were experiments where a company tried much smaller models to look at the code where Mythos found the vulnerabilities. And even as a model as small as a 3.6 billion parameter model was able to find all of the vulnerabilities that Mythos found. So again, Mythos did it better because it was looking across code bases. It wasn't looking at very specific lines of code, and it didn't hallucinate as much as the smaller models. But we already have this capability, so we don't need to wait for Mythos to start using these tools to find vulnerabilities and help us with security. A very important point here is to keep the builder and the evaluator separate. So you should have tests that the builder hasn't seen that the evaluator or the verifier agent is using. This is very important because AI has a very big tendency to overfit. So it's very important to have different tests. And again, don't rely solely on AI as your verification layer, but it definitely should be part of it. Okay, having said that, you also need as many deterministic checks as possible. And these deterministic checks shouldn't be bypassed by developers. So they should be non-bypassable deterministic checks as part of your CI. Of course, we've had these. This has always been best practice as part of continuous integration. And you should have tests. So the typical unit tests, end-to-end tests. You should be checking whether you're meeting the acceptance criteria, of course, but then you should also introduce things like fuzzing. So you can easily do this by creating open API specifications from your APIs automatically. You should be doing property-based testing. You should be testing for invariants. So what things must always remain true. Again, to catch any issues where AI changes something that wasn't in scope, especially. And then again, very important, you should have tests that the builder agents have never seen. So test-driven development is not enough. And then you should have other, again, typical tools like SaaS tools to catch vulnerabilities. Looking at the supply chain, very important. We've seen the Axios vulnerability recently where someone injected a malicious dependency into Axios, which is a dependency in many projects. You should have secret scanning. So another problem with AI is that it tends to hard code a lot, and you don't want hard coded secrets, not even if they are developer secrets, in your code base. Sometimes you might need to bypass this, even though we're calling them non-bypassable gates. But in that case, you need to have very, very strict policies and rules of how that can happen. All right, so AI can and should help with our work, but accountability is still human. And I think at a minimum, you need these two things. So you need someone to take responsibility, to take ownership of the intent. So capturing the requirements, the specification requirements. Then you need someone to translate those into the technical and someone verifying that that's actually what's happening in your code. And then you need to obviously have someone that's taking ownership of verifying from a functional perspective. Now, these don't need to be different people, but you definitely need someone taking ownership of all of these. And you also need traceability. So this is another criticism that StrongDM received, which was traceability. And the way they solve this is that now whenever a human starts an agent or an environment where the agent lives, that environment or that agent are cryptographically signed with the private key of that human. So everything, any deliverable by that agent can be tied back to that human. Traceability is very important. So that's all the front work. But you also need to be ready when things go wrong, and they will. Even with all of those controls we talked about, things will still go wrong, so you need to be ready for it. And we've all seen ancient documentation that's stale, that doesn't really help. So rather than focusing on that stale documentation, you should be preparing your code base and your environment so that you can gather the right information at the right time, especially now that we can use AI to do that, it's great at doing that. So to do this, you need a lot of the things that we were talking about, like clear contracts, like plans that are persisted. You ideally have simple descriptions of all of your modules at module level, usually in Markdown files. That really helps AI navigate the solution better and the code better. You need to be using standard structures for all of this, for your code, but also for your documentation. We mentioned Open API specifications for your APIs. AI loves standards, and then you just need to have a clean solution. So there's always the question of, do we need to maintain a clean solution if AI is writing most of the code? But yes, you still need it because it helps AI and it helps regression issues and all of that much better. And all this helps us build relevant information through agents and through AI when we need it, which is much better, obviously. You also need to roll back if you need to, and you need things like feature flags, like rollback plans. You need good observability, both for the humans, but also for the agents. And then you obviously need to be testing this, not when things go wrong, but you need game days to make sure that these things actually work. So in a small team, people can improvise most of what we talked about, but at an organization scale, that will lead to chaos. So you don't want things living on the developer's machine. And if you have that, that's a disaster for auditing, and you'll definitely fail a SOC 2 audit. So you need to be having these things managed by the organization. Platform engineering becomes very, very important here. And other than that, you can also do more useful things. So you can have agents notified when there's a failure on production. They can look at logs. They can look at change history, the releases. They can collect all of the information. They can come up with theories of why things went wrong. They can come up with possible fixes so the humans can just review or move much quicker. And I think this is where the guardrails really help, because we can automate more by having the guardrails in place. And with that comes more spend. So that's where AI FinOps comes in. So we need to be careful of how we're spending tokens. So if we have the agent that we just talked about running on the platform and they go into a loop trying to identify an issue, that will rack up a huge bill. So token economics matter a lot, especially on the cloud. You don't always need the frontier models. Like we've seen, even the small models could find issues that Mythos could find. And frontier models can cost up to even 38 times the smaller variants of the same models. So also make sure that you obviously have budgets and caps and kill switches for these agents that are running on your platform. So after looking at all that, the sensible question is all of this helping? And in 2024, Dora found that it wasn't. It actually had a negative effect. So developers were less productive by using AI, but that changed in 2025. So in 2025, in the 2025 report, Dora found a positive effect to developers using AI. And I think since then, things have only improved. So a lot of people are calling November 2025 an inflection point, and maybe April 2026 with Mythos is another inflection point. We're not sure yet, but security researchers have been saying that it's a game changer, and they found a lot more issues now with Mythos. So very importantly, you need to be looking at the right metrics to measure whether AI is effective or not. And the three main important pillars are whether your AI adoption, how that's affecting speed, and how that's affecting quality. So you need to be measuring across all of these three pillars. And looking at the right metrics, very important. So Amazon had this great idea to mandate AI use, and they suffered huge issues. So someone even deleted a production environment and wiped out 6.3 million orders because of this. And part of the solution they had, by the way, for this is that now they mandate code reviews by senior developers, and that allows for also a lot more accountability in the process. So code reviews are still important. Accountability is very important. This is a project at Cleverbit that we've deployed in our teams. So what we're doing here is that we're looking at transcripts between developers and agents and any context that is added to the conversations. We analyze these threads and we qualify any big decisions that were taken by the agents without any human input. And then we present a report to the developer. So we use this for three things. So first, the developer can find any gaps and course correct early on. Then the developer can just improve the way they're instructing AI. And we're also gathering some heuristics so that we can have a proxy of this drift that we've been talking about across the various teams. So this is quite an interesting project that came out of our R&D, and we're deploying this across our teams. Now, this is the full workflow that we talked about. So you have the contract, again, the requirements, what's in scope, what isn't in scope. You have the plan, both at a high level, at an architecture level, but also the developer plan. You have automation. Automation is very important. Deterministic checks are very important. Checking for risks automatically as well is important. And you're capturing risk across these three levels at a minimum. Then you have code reviews. Code reviews are still important. Spot checks are very important to ensure that there are no inconsistencies. You probably cannot look at every single line of code, but you should still be looking at the code. And then you have some sort of evaluation, verification, both by AI, but also by humans and general automated tests that we've always had. You need to be ready for it when things go wrong. You should have everything that's traceable, again, at an organization level. So all of this needs to be governed at an organization level, and you need to be measuring the right things. And that's roughly the operating model that we talked about. All right, so moving on to the conclusion. So a quick recap of what we talked about. So you should be focusing on the better instead of the faster, and that doesn't mean slow down. So it means you're in a better position to speed up. Rigor you need varies by risk, very important. Accountability is always human. In enterprise SDLC, dark factory is not the destination. Don't trust AI generated code. Old measures aren't enough, so don't rely on code reviews. Tooling is a very big threat. So you need to be doing threat modeling also on your tooling, and measure the right things, not vanity metrics. And a robust platform is very important to have organization-wide safe adoption. Now, what you can audit first to look at what risks you have across the organization. So first of all, capture risk associated with AI change. Are you measuring the right things, or are you simply focused on adoption and code speed? Very important, again, DORA metrics and so on. Do you have strong instructions, or are you giving AI very vague stories? Are your agents running with developer's identity, or what permissions are you giving your agents? Can you recover from failures quickly? So again, continuous readiness becoming more and more important. And what level of traceability do you have across the phases? Right, that's everything I had prepared for you today. I really hope you found it interesting and helpful. And thank you for joining. Back
Thanks.
to you, Simon.
We have so if anybody has questions, do put them into our into the question chat. So two have come in. So one is you mentioned Dora found mixed productivity gains. How do you practically measure whether AI is actually improving delivery at a system level, not just developer perception?
Okay, yeah. So yeah, in 2024, they found a negative correlation. So we also need to keep in mind that with these research projects, we're looking at previous generation of AI models and tooling. So it's very important to keep that in mind. Like I said, so you need to be measuring across the three pillars. So you need to be measuring at adoption, need to be looking at adoption, at speed, and at quality as well, all of those three. I think DORA metrics are a great place to start. So they cover a lot. Or maybe you can look at space metrics as well. In DORA 2024 introduced a new metric, so they're looking at fixes needed after deployments. So they're looking at it more holistically as well. I think the problem with DORA is when you don't have continuous delivery dialed in. So if you're using, for example, a hybrid approach like hybrid waterfall, and measuring there is not as straightforward.
Yeah.
So I think in that case, you need to be looking at typical metrics like schedule performance index, for example, and defect rates. But again, very important to be looking at all of the three all of the three pillars.
So another question, if you had to choose one, move fast with AI and accept that you don't fully understand or control what's being shipped, or slow down enough to retain ownership and accountability. Where do you draw that line as a CTO?
Right, so this is very contextual, I think. So I think, like I said, the dark factory approach can apply to some things. So if you're a startup and just want to determine market fit, for example, and you're not dealing with personal data or anything high risk, you can absolutely benefit from churning code and shipping as fast as possible. We talked a lot about risk, so I think it depends a lot on the risk appetite. I think for professional product or an enterprise project, I would certainly not go above that threshold that we talked about. I think accountability is a lot more important.
Okay. Um, boom, boom, boom. So how does the use of AI for code development affect our intellectual property rights? I think you hinted at this. So we're talking about copyright, trade secrets, or potentially also patents.
So again, it depends a lot on the context. So
Yeah.
first of all, you need to be making sure that you're controlling these at an organization level. So a lot of these companies and uh, cloud service and cloud providers offer siloed environments where you can work in. We also do have clients actually that are running AI locally in their on-premise servers. So it depends on your risk appetite, really.
Okay. I think we have time for one more question. Do you think product managers can or should touch the code base? What do you think about new roles like technical product engineers?
Yeah, so we're very much focused on the typical SDLC and the developer lifecycle, but I think that we have an opportunity for a lot more outside of that with leveraging AI. So something we've also been doing, for example, is have uh, UX designers and product owners also create prototypes through AI to test out certain ideas, for example. So I think most people in the organization should be touching AI and potentially should be touching code as well, which is a bit more controversial, but there are a lot of opportunities there outside of the professional development as well.
Yeah, and again, I mean, it depends on the context. Like the context is really a driver of a lot of these decisions.
Exactly.
Um, okay, there's one more. It's a long one, okay? So it's a bit of a mouthful. So as some context to these big changes, we have to remember that the process of code reviewing has been considered lacking for a long time. Many people don't really read what they're looking at or take in the big picture. While the AI coding may make code reviews harder, is it really that much worse due to that? And then there was another follow up to that also. What do you think of the idea of prompt reviewing instead or as a supplement?
I think it's a supplement, definitely. I think reviewing the plans, the developer plans, is great. I think a lot of the issues really we're catching them there at this stage. And again, it's not the developer writing the plans usually, it's the developer together with the AI, and the AI is coming up with a lot of suggestions. So that helps because it's not themselves coming up with, they're not attached to the plans. I think it's much worse because coding is happening much quicker. So the volume of code reviews is much bigger now. And even from a psychological perspective, just people don't like reviewing code. So that's why it's that much worse.
Great. So I think we've covered all of the questions. So thank you everyone for joining this webinar. We've had a real record attendance. Really good to see many new faces and really high engagement. Thank you everyone. Thank you everyone at the Cleverbit team for putting this together, and especially Cleverbit Software's R&D team that are always doing research on best practices. And thanks to them, it allows us to share this information with you guys. So thank you everyone, and have a great weekend.
Thank you all. Thanks. Bye-bye.